Yes. Good evening. So, good evening, students. Welcome to Let's Crack CBSE Science and welcome to my class. Let's wait for a few more minutes for the others to join and then we'll pitch in. So, as discussed earlier, today we'll be dealing with the searching algorithms. I'm sure it's very clear from the title of today's lesson. So as you all know, we have been dealing with class 12 computer science. So we have started with the study of the programming language Python. Then after that, we entered into data structures. Now, as per the syllabus, NCRT syllabus for class 12, you had to learn both stack and queue. Now, apart from that, you have to understand and learn sorting techniques and searching techniques also. We had already had a session on sorting techniques. Today, we'll be looking the continuation of it. We'll be looking into the searching technique and the searching technique implemented using linear list in Python. Okay. Just 1 minute to go. So we'll just wait for 1 more minute and then we'll start. Yes, Angel, very good evening and welcome to my class. So, yes, it's time and let's begin. So, very good evening and welcome to Unacademy and welcome to my class. So, before moving on to our lessons, let me give you a self introduction. Hello, I'm Shalini. I'm a BTech and MTech holder in computer science and engineering. I'm a teacher by profession with over 14 years of teaching experience teaching various BTech undergraduate students. With Unacademy, I'm excited to provide an inspiring learning experience to all the students via this online platform. So, as you all know, Unacademy has grown out to be India's largest e learning platform. As I told you before, and as I keep on telling you, it is not just because of the pandemic situation that the online platform has gained its importance, but also for the reason that it is a one stop destination whether you are a CBSE school going student or an aspirant who is preparing for a competitive examination, you get almost all courses underneath this one stop destination, and hence, an academy has grown out to be India's largest e learning platform. So, what you get to see in an academy, you get access to daily live classes. All the courses here are well structured and in line with the current examination syllabus. So this would help you to prepare for the forthcoming examination better. Now, apart from all these things, there are also live tests and quizzes conducted by the educators as well as by the app. Now, this would help you to evaluate your preparation and gives a detailed analysis of how well you are performing or preparing for the forthcoming examination. Now, once you get a subscription to Unacademy, you get unlimited access to all the resources here. So you needn't worry if you miss out a live session because there is a possibility of viewing the recorded version of the same once you have a subscription to the app. Okay. Now this can be viewed at the comfort of your time as well as your device. Okay. So this is how a comprehensive syllabus would look like for a school student. Now you would have the different subjects and underneath each subject you would be having the different courses, the courses offered by the best educators all over India. So what you just need to do is underneath each of the subject you can go click on the courses according to your taste and requirement and watch the lessons. So how to get access to all these things? First thing what you need to do is you need to download the Unacademy learning app in your smartphones. Okay. So you need to download it from the Play Store and install it and then get the subscription based on your choice. Yes, good evening Surabhi. Welcome to Unacademy and welcome to my class. And apart from that, there is a Telegram channel too. Now, to get access to the channel, all you have to do is download the Telegram app and see the link here, Quest 12 CBSE Commerce. You need to type the link in the URL as shown in the figure and click to join to the channel. Now, in the channel, you get access to the resources posted by the educators regarding study materials, the updates of the classes, etc. Yes, Riyansh, very good evening and welcome to my class. So here, this is a detailed description on the class 12 subscription fee. Now below are listed the different plans ranging from 1 month subscription to a year subscription. Okay. And across each of the plans are listed the cost or the amount, the fee, the subscription fee. A month subscription plan, the fee ranges from 2,500 to a year subscription, which is ranging to 12,500. But on applying my promo code SLYT, I repeat, on applying my promo code or my referral code SLYT, you get a discount of 10% on all the slabs that are being shown here. Okay. So a month subscription which costed you around 2,500 after applying my referral code would get reduced by 10% and it would cost only 2,250. Now, in similar way, you would get the same discount in all the following plans also. So using my promo code doesn't mean that you get access only to my classes, but also to all the classes that are posted by all the educators. So you can view according to your choice and taste and also at the comfort of your time. Okay. So that's all about Unacademy and let's get started with the agenda of the day. As you all know, we have been dealing with class 12 computer science and today we'll be looking into the various searching algorithms that we have to learn as part of data structures. Okay. So primarily we'll be looking into two portions that are the two searching techniques that you have to learn, primarily the linear search as well as the binary search. So we'll have the algorithm as well as a small code to help you how the implementation in the language Python for the same would be done. Okay. Yes, so yes, good evening. And so searching. Now, as per the definition, searching is the important activity of a data structure. Now, this is an operation, permissible operation in any data structure. In the previous class, we had already seen the various operations that could be performed on any data structure, right? So, we had seen insertion, then we saw the operation deletion, right? And then traversal across the data structure. We also saw searching, sorting, and even merging could be done. Okay, so we have come across almost all the operations in each of the data structure, and we had a separate session in which we learned about sorting techniques too. Now, today we'll be learning the operation permissible in data structure, which is called as the searching. So, it is an important activity of data structure in which a particular element is searched in order to find its location. Okay, so it's not only for finding the location. Now, when do you get the location? You get the location when you know that the element is present inside the data structure. Okay, so the ultimate aim or the ultimate output, primarily what you get is whether the key element is present in your data structure or not. So this is the first thing that you get. After that, once if the element is present inside the data structure, definitely you get access to the location of the element too. Is the idea clear? So searching is a technique in which you find out whether a particular element is present inside your data structure or not. Now, if it is present, we do display the exact position or the location where you found the key element inside the data structure. Okay. So in Python, a target item or the key can be found in a sequence using the in operator. Okay, so in the language Python, the key or the target item is found in a sequence. Now, what is a sequence? Sequence is nothing but the data structure in which the values or items are stored as a sequence. So, in such a sequence, how do we find the target item or the key value? We find it using the in operator. Yes, Ismail. Very good evening and welcome to my class. So today we are dealing with the searching techniques in linear list. Okay. So in Python, now this is a very sample syntax to show you how or whether the element is present inside the data structure or not. Now, as I told you, we are trying to perform the searching operation in the linear list, right? So I use the if conditional. How do I write? If key in list. Now in is the membership operator. Now what does in check? In checks to find whether the value is present in the list or not, right? Now if it is present, I would display a message stating that the element is present in the list. Otherwise, I print the message that the search is unsuccessful. Okay. Now the next thing that you need to note here is, see, I have to travel through each of the elements in the list and then find out whether the element is present or not, right? Not just a single position, but I have to traverse through all the positions inside the list. In that case, such a code fragment would not be sufficient. Then how do you have to write it? You have to write it using a loop. Now, what does a loop do? It would iteratively perform the same searching operation from each position in the list. Starting from the very beginning, it will be traveling till you reach the end of the list. So each of the position inside the list is scanned and then checked against for the existence of the key value. So this is how a searching technique would be performed in a linear list. Okay. So moving on. So these are the different searching algorithms that you have to learn. The different searching methods or the algorithms are linear search and binary search. Okay. Now, the little meaning of the word linear search, so you're moving along a line. Okay. So, moving in a sequence, that is what linear search means. Now, binary, what does bi mean? Bi meaning two, right? So, in a binary search, what it does is it divides your entire list into two, and each time the size of your list get reduced to half of the actual size. So this is how you reduce the size of your list and then focus your search in the very smaller portion. In the end, either you find the element or you come out without finding the element. So either the search would be successful or unsuccessful. In both the cases, we would be printing the messages. Okay. So in linear search, each element of the linear list is compared with the given item. Now, what is the item here? It is a key value which you need to find whether it is existing inside the list or not. Or it is simply the value that is accepted from the user, and then you are trying to check whether this value is present inside your list or not. Now, how do you do it? Each element of the linear list is compared with the given item to be searched for one by one. So, each position by position wise, you would be visiting, traveling each of the position and then checking for whether there is a matching, right? You have the key value which is accepted from the user. You go open the list and search for each position and find whether they both are equal. Is the idea clear? So this is how a linear search does. Now, how does the linear search progress? It progresses from the very starting position till you reach the end of the list, right? So since this is happening one by one or in a sequence or in a linear fashion, hence the name linear search. Okay. Yes, Adarsh, good evening and welcome to my class. Yes, we are dealing with searching techniques in Python. So we'll be learning the two searching techniques, linear search and binary search, and a sample code for how you can write the user-defined functions for implementing them in Python. Okay, fine. So next, binary search. The binary search requires the array or the linear list to be sorted in any order. So this is a mandatory condition for performing the binary search. The list or the array has to be in a sorted order. Sorted either in the ascending order or descending order. So the binary search can only be performed in a sorted array, but that is not mandatory in the case of linear search. Okay. So in binary search, the item is searched for in smaller segment after every stage. So what happens in binary search, as I told you, every time the array or the point of your focus is getting divided into half or divided into two portions, and in each portion the search is getting triggered. Now we'll see as we progress in today's class how the binary search happens in the reduced format of your linear list. Okay. So moving on. So linear search. Now this method traverses the array or the linear list sequentially to locate the given item. Now we had already seen this in the definition of the searching technique, right? What does a method do? The method traverses the array or the linear list sequentially to locate the given item. Now, this given item is the item that you're trying to find its existence, or you're trying to find whether this particular item is present in your list or not. Now, since the search is done in a sequential order, position by position, you're traveling each one by one. And for this reason, the same searching technique is also called as sequential search. Is the idea clear? So, the other name for linear search is sequential search because the searching technique happens in a sequence in the order in which it is appearing. So let's see a very sample example. Now this is how an array or your linear list is going to look like. Now all the elements inside the array or the linear list I have shown in red font color. Now from here we start. Okay. Now key is equal to -2. Now this is a value that you are going to search inside your list. Okay. So you're going to check whether the element -2 is present inside your list or not. Fine. So now see here, you have index values associated with each of the items or data elements of the list, right? So what is the index value? We have the position or index value starting from 0 to how many elements are here? 5 elements. So since the position value is starting from 0, the last position value is 4, right? Now the elements inside your list are 10, 51, -2, 0 and 80. Okay. Now what are you trying to do? You're trying to find out whether an element -2 is present inside the list or not. Okay. So you start from the starting position, then first visit the index value 0. Now which is the element present inside the position value 0? The value is 10, right? So you try to check whether these two values are equal. You find that it is not equal. So that means -2 is not present in the very first index. Now you need to travel to the next index. So how do you progress it? Just increment your position value. Is the idea clear? Just increment the index or your position value to visit to the next location. In that case, the value is 51. Again, you check for a matching and you find that the element is not getting matched. Now, since the element is not matched, what do? You again progress to the next position, increment the position value. You go to the next position. Now, what is the value here? -2. Now, I do a check and I find that the values are matching, right? So, I found the presence of -2 inside the list, right? Now, since I have found it, I need it go further. I'm assuming, I'm breaking from the checking portion or the searching technique because I have found the first occurrence. Okay. So I'm not bothered about multiple occurrence of the same data element. So since I have found the value, I exit from the searching technique. Now, when I exit from the searching technique, I will be displaying a message stating that my search is successful and the value has been found in position 2. Okay. So this is how a linear search happens. Okay. Now, let us see another case in which we are going to find out whether the key value 100 is present inside your list or not. Okay. So, we as humans, when we view the elements inside the list, we know that 100 is not present. But how exactly the language does for the searching? So, it starts from the starting position to the very first index of the list. It go check for the element inside the list. Now, which is the element here? 10. So, not matching. So, definitely the position has to be incremented. It moves on to the next position. The value here is 51. Again, it finds that it is now matching. Now, the process continues. Now, each time it is incrementing the value of the element inside. I find that it is not getting matched because the value going to be searched is 100, right? So I move on till the last position and I find that I have come out of the list, right? I have traversed the entire list. Now, after traveling the entire list, what is the conclusion? You did not find an element with the value 100 inside your list. So, what is the conclusion? The conclusion is search is unsuccessful or the key value is not found inside the linear list. Is the idea clear? The key value was not found in the linear list. So these are the two possible outcomes when you're doing any searching technique. So need not be just linear search, but also binary search. So whatever be the searching technique, you either end up finding the element or you end up not finding the element in the given list. Now, if you find the element, you will have to display the position where the element is occurring also. Okay. So this is how the output is expected in the case of searching techniques. So progressing on to the next slide. So here is an explanation about the algorithm for the linear search. So what is an algorithm? Algorithm is a step-by-step explanation towards achieving your target. Now what is your target? Your target is performing linear search, right? So see here I see a few variables here. Now let me first introduce the um, yes, set is there in your syllabus, but I mean, I'm sorry. Set is also a data type, but I don't think you have to learn it in as per your syllabus because in NCRT the operations or the definitions of set is not defined. Okay, so all you have to learn is from the integers ranging, the data types ranging from the integers till the dictionary. Okay. So let me introduce the variables to be first. Now CTR is just a counter variable that I'm using. Okay. Now this is to progress through your list. Then L is the lower bound. Lower bound meaning the starting index value of the list. So it would be 0. Okay. And U is the upper bound. What would be the upper bound? The very last position or the index value of your list. Okay. So I hope these are the yes, and you have the name of the list as AR. Okay, capital A and small letter R. So let's start with the algorithm. So the very first step, what you need to do is you need to initialize the value of the counter. Now, in our previous example, what did we say? We started with a point start, right? And which was a very first position we checked. We checked with the index position 0 or the lower limit or the lower bound, right? So CTR or the counter variable is going to be initialized to your lower bound or lower bound, that is the value 0, right? And then you're going to repeat the steps 3 to 4. Okay, so steps 3 and 4 are going to be repeated till CTR or until CTR is less than U or the upper bound. So what does that mean? You are actually going to do steps 3 and 4 repetitively as you progress through each of the index positions in your list, starting from your lower bound, that is index 0, to the very last index of your list. So this is how you're going to progress. Now what are you going to do as you're progressing? As you're progressing along, now as you're progressing along the list, you are trying to find whether the value stored in the item. Now what does a variable item indicate? The item is a value to be searched. Okay. And AR is the name of your list. Okay. So what you're trying to do is you're trying to find whether the value in the item is present in AR or not. So how do you access each of the element inside the list? The name of the list followed by the index, right? Now, how is the index getting progressed in our algorithm? Using the variable CTR, right? So, 8AR of index, right? In this case, I'm trying to check what do I point by writing AR of index? I'm actually pointing to the element in the CTR, position CTR in your list, right? So if AR of CTR is equal to item, that means if the element is present. Now, what does the if conditional say? If the value in at the position CTR is equal to the value in the item. So that means you have actually found the value, right? So what are the things that you need to print? You need to print stating that your search is successful, as well as you need to print the position where you found the value. Now, how do you get the position? The position is your counter variable. Now, since you have found the occurrence of the item, is it mandatory for you to search the entire list? No, right? So you need to break from this point. So I use the jump statement break. Fine. So what will it do? It will break from the loop. Now this loop is going to continue from 3 to 4. So it would not be going to step 4. Instead it would be going to step 5. Right? Now I see that this condition is false, and then it would go to the end. So if the search is successful, it would be printing the message search successful, as well as it will be printing the location and then breaking from the loop. Now at every stage as you're progressing through the different positions, you find that in none of the cases you have found a matching. Okay, so in none of the cases, if you have not found any matching, what is the result? The result is that the search is unsuccessful. So that means you will come out of the loop without even going to 3.1 or 3.2 at any cost. Okay, so you would not be visiting these steps. So which is a case in which you will not be taking or considering all the sub statements inside step 3. This is a case wherein you have not found the item inside the list, or the data element or the value inside the list. So naturally the control would go to step 5. Now what is asked in step 5? We check for the value of the counter variable. We check if it is greater than u. Now when will you exit from the loop? When the counter value gets greater than the upper bound. So this is a condition in which you would be exiting. So I check if I had come with the counter value greater than my upper bound. In that case, I can peacefully print the message that search is unsuccessful, meaning that you have not found the particular item inside the linear list. Okay. So this is the algorithm. Now let us see how can we implement the same in Python. Okay. So I've just written the code fragment using a function. So how do you write the function definition? You write using the keyword def, right? Now what is the name for your function? L search. Now it meaning the shorthand form for linear search. Now you're passing two values as parameter. Now what are the values? The name of the list. What is the name of the list? The name of the list is AR, followed by the value that is to be searched. What is the value to be searched? The value to be searched is stored in the variable item. So these are the two parameters that you are passing in the function lsearch. Okay. Now what are you trying to do inside lsearch? You have to set the counter variable. Now what is the first or initial value for the counter variable is 0. Why? It is pointing to the starting index. Now what would be n? N would be the upper bound. Now how do you find the upper bound? Upper bound is found by finding the number of elements inside your list. Now, how do you find the number of elements inside the list? Using the function len, right? So, len is a built-in function, and whatever parameter you are passing inside the function len, it would give the count or the number of elements inside the data structure. Okay. So, n would definitely have the number of elements. I would be initialized to 0. So I is your lower bound, as we have discussed in the algorithm. And what is n? N is actually the total elements. Okay. So what would be your upper bound? Upper bound would be n minus 1, right? So how do you write? When you're writing a for loop, I would write for I in the range of n. Now what does range function do? The range function gives a series of values ranging from 0 to n minus 1 and not n. So n is not inclusive. It would be taking a value from 0 to n minus 1, right? So for I in the range of n, now what do I do? If AR of I is equal to item. Now what is this if conditional doing? This if conditional is checking whether the value at the ith position in the list AR and the value in the item, are they both equal? So you're checking whether you are finding a matching or whether you can find the element inside the list. Now if you try to find what you have to do, you need to assign the value of the variable I. What is I indicating? I is actually indicating the index or your position value, right? So I store the value of I in the variable pos, and then I'm writing immediately return. Now, what does return statement do? It comes out of your function, right? So, return statement is considered to be the very last statement of your function. But when will this particular return statement be executed or considered? Only if the if conditional evaluates to true. Now, what if the if conditional never evaluates to true? So that means you travel from the lower bound till the upper bound, and in no case you have found the item inside your list. In that case, your conclusion is that the item is not present inside your list, right? So what you have to do is, in this case, you have to write as, I'm sorry, there's a small mistake in the the alignment. It had to the indentation, so it had to actually start from here. Okay, so what you have to write is return false comma I, right? Now I need to see why did I give multiple values here. Okay, when we were learning functions, whenever we use the return statement, we usually had written only a single value as the return along with the return statement. Okay, so but in the functions we also learned that a function can return multiple values also. Okay, so how is a value returned? The value is returned using the return statement, and multiple values. Now how many, whatever be the values or how many values be it, it can be returned only using the return statement. Now how do you give the multiple values? After the return statement, the space, you would list the values separated by comma, right? So here, so naturally the place where you're invoking the function or you're calling the function will have multiple values on the left hand side, or it would be a tuple or a list on the left hand side, right? So in this case, if I'm expecting two values, so definitely definitely the last statement of your function should also be returning two values, right? So I have, for the time being, I have given false comma I. Now, what does false indicate? False indicate that the element is not present inside your list. Yes, I'm sorry. I think there's nothing wrong with the indentation. It is actually right. It had to come in alignment with the F of for loop. Okay, so I'm sorry for that. Now in this case, the return statement is a part of your if statement, and here the return statement is the return statement of your function. if when the if conditional is evaluated to false, and in neither case it is evaluated to true. Okay. So this is how the search happens. I mean, the linear search happens. We had already seen the algorithm, and then we saw the code fragment to understand the implementation better. Now, it has been illustrated, or the implementation has been illustrated using a user-defined function. Now, what is the name of the user-defined function? L search, right? So, L search is taking two arguments, sorry, two parameters. What are they? The name of the list as well as the value to be searched inside the list. So first you have to set the values of the starting index as well as the ending index, and inside the loop you will have to travel each position, okay, one by one. Now as you travel and visit each of the position, you need to do a checking to find whether the element in the list is equal to the element in the variable item. Now, if at any cost you find that they are matching, so that means this is the position in which you have found the element. So, immediately break, and when you're breaking, you have to return with the value of the position where you have found the element. So, this is how linear search would be implemented in Python. So, moving on. Now, the above function, I told you that the return statements, they are having multiple values. Okay, so see how the function would be invoked. Now since there is a return statement, so definitely at the point of the function call, a value would be returned, and this value has to be copied to some variable in the main program, right? So the above function can be invoked by the main program as the flag comma pos. Now what will flag contain? The flag will get either the value true or the value false. Okay, and POS will get the position value. Now the position is relevant only when the flag value is true, right? When is the flag value true? The flag is true when you find the element. That is when the search is successful, right? And when is the flag value false? False when the search is unsuccessful, isn't it? So what you need to do is, after the function call in the main program, all you need to check is, you need to check with the value of the flag. If the value of the flag is true, I would say your search is successful and you would print the value in POS. If the value is false, just give the message stating that the search was unsuccessful, meaning the element was not present in the array or the list. Okay. So what you need to do after the function invocation or the function call statement, you need to check for the value of the flag variable. Now this checks or see whether the element NO. Now this is a value that you're going to pass, right? So these are the actual arguments. So you check whether the element NO is present in the array or not. Okay. So this is how you perform the linear search. Okay. Now we have just discussed the function, code of the function for the performing linear search, and this is how you would be invoking the function. Now one more thing that you need to notice, you are returning multiple values here in the function statement or in the function body. And this is how you would be accepting or receiving the returned values from the function as such. Okay. So I hope this is clear to you. So moving on to our next topic. Now what is the topic? The topic is binary search, right? Now just a few words regarding the searching technique. It uses the concept of divide and conquer. Okay. Now how do you do divide and conquer? Um, Now this is the same policy as how the Britishers performed for invading India, right? So division meaning it is not the mathematical division, but instead we are trying to divide the given divide the given list or array into smaller segments. Now, you're dividing it into smaller segments so that your search becomes very easier. Now, in the case of linear search, see, the worst case was you have not found the element in the list. In that case, you need to start your search from the very first till the end of your list, right? And in all the cases, you have spent all the time and energy, but you have not found the element. Now, what binary search does is it tries to reduce the time taken for the searching technique. What exactly it does? It does is it reduces the time taken for performing the searching technique. Now, to reduce the time, it uses the technique of divide and conquer method. Now, how it does it? Let's see. So what it do is it repeatedly divides the array or the linear list in our case into pieces. Now what it does is it will divide your entire array or list into smaller segments or pieces and refocuses on the piece that would contain the target value. Okay, so the conditions are written in such a way so that after the division of into pieces, we refocus to find whether the target value is present in the smaller segments or not. Okay, so usually the binary search is done as a recursive function. Now here we'll be discussing a non-recursive pattern. Now, binary search is more efficient than linear search. This is something that we really need to know when you compare and start learning the two searching techniques, which are the binary search as well as the linear search. The conclusion is that the binary search is more efficient than the linear search. Why? Because in the linear search, you will have to travel the entire array one by one. But in the case of binary search, the number of searches or the number of searching done is reduced here. How? Because each iteration reduces the search by a factor of 2. Okay. So it is actually reduction. So actually reduced meaning reduced by 2 meaning reduced as half. Okay, so the entire search is reduced to its half. Okay, now the very important point next to be noted is binary search works only with the sorted list. Is the idea clear? So though it is more efficient than linear search, this is the most important thing that we need to keep in mind. It works only with sorted list. So the list has to be sorted first prior to performing the binary search. Now, if you're having an unsorted list or the user has entered an unsorted list, the first thing to be done is sorting your list and only then performing the searching technique. Now, for sorting, we have already learned the sorting techniques, and as per the syllabus, we have learned bubble sort as well as insertion sort. Okay. So either of these techniques can be used for performing the sorting of the list prior to your binary search. So these are the theoretical details with respect to binary search. Okay, now let's have an example here. Now look at this example. Now in this example, you have a list. Okay, now how many elements does the list have? It has 5 elements. Now all the elements are shown in red font color. Now the values that are written above them are nothing but the index or the position values. Is the idea clear? Now the values written on top of the list are the index or the position values. Now the convention is that for a list it starts with the index value 0, right? So since you're having 5 elements, what will be the index value of the very last element? The very last element would have the position or index value 4. Okay. Now to perform binary search, what it does is As I told you, the searching technique tries to divide your list into smaller segments, right? So in this case, the first it would go and search the value in the middlemost position. Okay. Suppose your key value to be searched or the item to be searched is 5. What happens? First, the middle position is calculated by low plus high by 2. Now, after performing this operation, you would get the value of mid, right? So, find the middle position and then go and search for the value in the middle position. So, in this case, if you find that the value is present in the middle position, yes, your search is successful. But if you do not find the value matching here, what is the next thing that you have to do? Now we find that the element is not present in the middle position. Now you have to refocus your search either to the left of the middle element or to the right of the middle element. Okay. Now since you're dividing with from the mid position, actually you're having two portions of your list. Okay. One is the left side of your mid value and the other is the right side of your mid value. Now whatever be, it is similar to a slicing. Okay. But in the slice, the middle element will not be considered. Right. Now each of these slices is again a list. Right. Now after slicing, each of the portion either on the left hand side or on the right hand side is a list. In this case, what happens is, again, now we need to check if the element is not present in the middle position. We need to check whether the key value is greater than the middle element or lesser than the middle element. What if the key value is greater than mid? Then you need to focus your search on the right hand side, right? So if you find that the element is greater than the element in the middle position, so definitely you needn't bother about all this portion and then focus your search on the sliced list, that is from the position 3 to 4. Okay, see how you have reduced your searching. Instead of searching your entire list, now you have first checked the middle portion and based on the value, you have focused your search to a portion or a slice of your list and not the entire list. Now, this is how binary search is more efficient than linear search when you consider the time of execution. I hope that is clear to you. Now, suppose there can be another condition also wherein the key value is less than the value in the middle position, right? In that case, where have you to focus your search? You need to focus it on the left hand side or the slice portion of your list on the left hand side. So this is how the searching technique would be progressed. Now, in this case, again the slice portion is a list, right? Wherein you would be reiterating with the same procedure. Now, what is the procedure? You need to find the middle position or the middle element. First search in the middle position. If you do not find the element there, again refocuses it by again further dividing it. So hence divide and conquer method used in the case of binary search. Now the method itself state to you that we are not searching the entire list for the for finding the presence of the item or the key value, right? Instead, we are subdividing your entire big list into smaller portions and focusing your search on very, very small portion. So likewise, it is very, very far better than the linear search. When you consider the worst case of analysis in a linear search, what happens? You'll have to travel till the end of the list, right? So this, when you're considering the time as well as the space of the processor, it is a very hectic job. So, but when you're considering the binary search, it is far more easy. Yes, Verghese, good evening and welcome to my class. So I hope the binary search, the idea of binary search is clear to all of you. Now, a little more theoretical details about how we did the searching. To search for an item in a sorted array, so this is something that you really need to keep in mind. If you have to perform binary search, the primary condition is that your array has to be in the sorted order. Right now, we saw the example wherein we had the sorted list. How was it sorted? It was sorted in the ascending order, right? Or in the increasing order. Not mandatorily ascending order. You can have it sorted in any order, okay? So to search for an item in a sorted array arranged in the ascending order, the item is first compared with the middle element. Now, how did you calculate the middle element? You have the lower bound as well as the upper bound. Take the average of these two values, you end up in the middle position. Fine. Now, if you find that the element is not present in the middle position, then you need to refocus your search, right? So you're definitely going to divide your list. So either you will check in the right hand side, that means the latter part of your new segment, or you would be focusing your search on the left hand side, that is the former part of the segment. So this is how iteratively you would be performing the binary search. Now the process, now all the above bullets, how many bullets were there? 3 bullets, right? Now all this process is repetitively done until you find either the item is found or the segment get reduced to a single element and you find that even that single element is not the target item. In that case, you come out finding that your search is unsuccessful or you have not found the item. Okay. So here is the algorithm. Algorithm is nothing but we have written in steps as how we have explained the entire thing for binary search. Now the name of your list is AR. The lower bound is small l and the upper bound is U. Okay. So the first index or L by default it would be 0 starting index position and U the upper bound. So if this is in the initial case, L would be 0 and U would be the last index. Okay. So I have assigned the value of L to BEG, the shorthand form of beginning, and the value in U to the variable last. Okay. Now what I'm trying to do is every time I am checking whether the value of beginning is less than last. Okay. So if this is a condition, I need to make sure that this condition is true. Only then the repetitive action is performed. Now the action is performed from step number 3 to 6. Okay. Now when you exit from the loop, you exit from the loop when you find that the value of BEG is not equal to last or gets greater than the last. Okay. So the very first beginning. Now the first thing that you need to keep in mind is the list is sorted. Right now we are trying to, we are assuming the binary search in an ascending order list. Okay. The sorted, which is sorted in the order of ascending order. Fine. So first we calculate the middle position. So beginning plus last by 2. Now, when you're trying to find the average, you can end up getting a floating point value also, right? So when you get a floating point value, we know that the index values are integral numbers and not decimal numbers. So you end up getting a floating value, the system gets confused. So what you need to do is, whatever value that you get has to be typecasted to integer type. So to reduce the confusion, when you are ending up in a float value. Yes, good evening, Gokul. So we have been learning the searching technique and right now we are into the binary search. Okay. So first I start checking the element at the middle position. right? So I check inside the list the value in the middle position. Is the value equal to the value in your item? Now, if this conditional goes true, what does it mean? It means that you have found the item at the middle position. Now, do you think you need to travel the entire list? No, right? You can quit by printing search was successful and it was found at the position. Now, which was the position? It was found at mid. Now, to no more further going, you can use the jump statement break. Now, what will break do? It will completely exit from the loop, right? So when you're exiting, you check for this condition. This condition is not true, so this message wouldn't be printed on the screen. Okay. But what if it was not found in the middle position? Now I go on checking if the value in the middle is less than the item, or if the value in the item is greater than the value in the middle position. Now in this case, you found out that you're trying to find out if the item is greater than the value in the middle. So definitely you need to search on the right hand side, right? So the latter part of the segment. In that case, see, this is your, imagine that this is your list and these are the index values. You first check at the middle position, middle is 2, right? Now I find that it is not present in the middle position. Definitely you need to check if the value in the item is greater than the value at this position. If it is greater, you need to search in the latter part, that is in this segment, right? Now your new beginning would be 3 and there is no change for your upper limit. So what is the change that you need to make here? If this condition goes true, just alter the value of BG as 2 was in mid, right? So what will be the position 3? Mid plus 1. So just alter the value of beginning. You needn't change the value of last. But what if the value in the item is less than the value in your middle position? So that means your search has to be focused in the former part. Fine. That is before all the values before the middle element. In this case, yeah, you needn't change the beginning value, which is already your first value or lower bound. What is to be changed? What we need to change is the last value, right? So how do I change it? I write last is equal to mid minus 1. So this is how the change has to be brought. Now, what does the loop take care of? The step number 2. What it does is, it would take care that the steps 3 to 6 is performed as that many number of times till you end up with no more elements to be searched, or you end up finding the element. So this is the this is a point at which you would be exiting or you would be coming out of the loop. What are the two conditions? Either you find the element or you would come out of the loop completely with a negative result. What is a negative result? That the search was unsuccessful. Now in this case, when you're coming out of the loop, what do? You check with the condition if the value of beginning is not equal to last. Now, if this is the case, my search was unsuccessful. Is the idea clear? My search is unsuccessful. Now, for all the other cases, you would get a remarkably positive result stating that my search was successful. So, the foremost thing that you need to keep in mind while you're performing binary searches, whatever happens, your array or the elements inside the list, linear list, has to be in the sorted order. Now, this is a case there we discussed when the elements are in the ascending order. Now there is just a slight modification in your if conditionals in step 5 and 6 to be made if suppose your list is sorted in the descending order. See, this is the only change that you need to make. So if AR of mid is less than item, you need to change the value of last. And if AR of mid is greater than item, you need to change the value of BEG. Now this is a very smallest and slightest change you need to make when you are trying to perform binary search in the array or the list which is in the descending order. So do keep in mind that it has to be in the sorted order prior to searching. Okay. So with this, we have come to the end of today's session and we have learned all the searching techniques as per the syllabus. Which are the searching technique that you had to learn? Linear search as well as binary search. Now, the concept of arrays is implemented in Python using linear list, and so both the techniques we learned using linear list. Now we had small examples as well as code fragment to explain the same. I hope all of you could follow it, and for those who have joined late, I would recommend you to see the recorded version of the same so that it would be more understanding to you. So before bidding good night, let me remind you of my promo code SLYT, my promo code SLYT, which would fetch you in getting a discount of 10% if you're availing the Unacademy subscription. So please do follow me in the app as well as in YouTube so that you get notifications of my classes, and let's have a healthy learning together. So thank you all for attending and good night to all my dear students. So hoping to meet you all in the next class with yet another topic. So very